Azure Active Directory Federation. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with focus on networking. Also, hit the bell icon to get notified of new videos. Today we are exploring Azure Active Directory Federation, a critical component of modern enterprise identity management. Federation is fundamentally about establishing trust relationships between different identity systems, allowing users to access resources across organizational boundaries without maintaining multiple sets of credentials. Think of it as a passport system for digital identities where your home organization vouches for who you are to other organizations. Azure Active Directory, now known as Microsoft Entra ID, serves as Microsoft's cloud-based identity and access management service. When we talk about federation in the context of Azure AD, we are discussing how this service can establish secure trust relationships with external identity providers. This is particularly valuable for organizations that need to provide access to partners, customers, or employees from acquired companies without forcing them to create new accounts. The core principle behind federation is the separation of authentication from authorization. Your home identity provider handles authentication, proving who you are, while the service provider handles authorization, determining what you can access. This separation creates a more secure and manageable identity landscape, especially for organizations dealing with complex partnership networks or hybrid cloud environments. Federation core concepts. Understanding federation requires grasping several fundamental concepts that work together to create a seamless identity experience. At its heart, federation is built on the concept of trust. When two organizations establish a federation relationship, they are essentially creating a formal agreement where one organization agrees to accept identity assertions from another. This is similar to how countries recognize each other's passports, but in the digital realm. The identity provider, often abbreviated as IDP, is the system that knows who you are. This is typically your organization's directory service, which stores your username, password, and other identity attributes. When you attempt to access a federated application, you always authenticate with your home IDP, never directly with the service you're trying to access. This is a crucial security principle because it means your credentials never leave your organization's control. The service provider, or SP, is the application or service you are trying to access. It does not store your credentials or authenticate you directly. Instead, it trusts the identity provider to perform authentication and relies on security tokens to verify your identity. These tokens are digitally signed assertions that contain information about who you are and potentially what you are allowed to do. The Federation Protocol is the language that identity providers and service providers use to communicate. The most common protocols in Azure AD Federation are SAML 2.0, WS Federation, and OpenID Connect. Each protocol has its own way of exchanging identity information, but they all accomplish the same basic goal of securely transmitting identity assertions from the IDP to the SP. Federation benefits and use cases. Federation delivers significant value to organizations dealing with complex identity management scenarios. The most immediate benefit is the enhancement of user experience through single sign-on capabilities. When federation is properly configured, users authenticate once with their home identity provider and gain seamless access to multiple services without repeatedly entering credentials. This dramatically reduces password fatigue and the associated security risks of users writing down passwords or reusing them across services. From a security perspective, federation centralizes authentication in the organization's identity provider, which is typically the most hardened and monitored system in the environment. This centralization means security policies, multi-factor authentication requirements, and conditional access rules are consistently applied regardless of which federated service a user accesses. If an employee leaves the organization, disabling their account in the identity provider immediately revokes access to all federated services. For partner collaboration scenarios, federation eliminates the need to create and manage guest accounts in your organization's directory. Partners authenticate using their own organizational credentials while your Azure AD determines what resources they can access. This approach significantly reduces administrative overhead and improves security by ensuring partners never have passwords in your environment that could be compromised. The business-to-business scenario is particularly powerful in Azure AD. Organizations can establish federation trusts with suppliers, vendors, or partner companies, allowing their employees to access specific resources, like shared applications or collaboration spaces. The partner organization maintains full control over their users' identities while your organization maintains control over resource access, creating a clean separation of responsibilities. SAML 2.0 Federation Protocol. Security Assertion Markup Language version 2.0, universally known as SAML 2.0, is the most widely adopted federation protocol in enterprise environments. SAML is an XML-based protocol that defines how identity providers and service providers exchange authentication and authorization data. Despite being older technology compared to modern alternatives, SAML remains dominant because of its extensive adoption and proven security model. The SAML protocol operates through a carefully orchestrated exchange of XML messages. When a user attempts to access a SAML-protected application, the service provider generates an authentication request, which is a signed XML document, asking the identity provider to authenticate the user. This request can be transmitted to the identity provider either through the user's browser using HTTP redirects or through HTTP post operations. The identity provider receives this authentication request and prompts the user to authenticate if they have not already established a session. After successful authentication, the identity provider constructs a SAML assertion, which is an XML document containing claims about the user's identity and potentially their attributes and group memberships. This assertion is digitally signed using the identity provider's private key to prevent tampering. The assertion is then transmitted back to the service provider, again through the user's browser. The service provider validates the digital signature using the identity provider's public key, which it obtained during the federation trust configuration. If the signature is valid and the assertion is within its validity window, the service provider grants access based on the claims in the assertion. This entire exchange typically completes in seconds, appearing seamless to the user. SAML components and structure. A SAML implementation consists of several critical components that work together to establish and maintain the federation trust. The metadata document is perhaps the most important artifact in a SAML federation. This XML document describes the capabilities and requirements of either the identity provider or the service provider. It includes crucial information, such as entity identifiers, certificate information, and endpoint URLs where SAML messages should be sent. When establishing a SAML federation trust in Azure AD, you typically exchange metadata documents. Azure AD publishes its metadata at a well-known URL that includes your tenant ID. This metadata tells service providers everything they need to know about how to interact with Azure AD as an identity provider. Similarly, when configuring Azure AD to trust an external identity provider, you import that provider's metadata document. The SAML assertion itself is structured as a series of statements. The authentication statement declares how and when the user was authenticated. The attribute statement contains claims about the user, for example, their name, email address, group memberships, or any custom attributes your organization wants to share. The authorization statement, though less commonly used, can express what the user is permitted to do. Certificates play a vital role in SAML security. Each party in the federation maintains a certificate whose private key is used to sign SAML messages, and whose public key is shared with the other party for signature verification. Azure AD rotates its signing certificates automatically, but organizations must monitor for these rotations and update their service provider configurations accordingly. Many SAML implementations support multiple active signing certificates to enable smooth transitions. WS Federation Protocol. WS Federation is another federation protocol that predates SAML 2.0 and was primarily developed by Microsoft, IBM, and other vendors as part of the larger WS Star family of web services specifications. While SAML became the dominant standard in cross-organizational federation, WS Federation maintains strong adoption in Microsoft-centric environments and continues to be supported by Azure AD for backward compatibility and specific integration scenarios. The WS Federation protocol differs from SAML in its communication patterns and message formats, though it accomplishes the same fundamental goals. WS Federation uses a simpler, more streamlined approach to initiating authentication. When a user attempts to access a protected resource, they are redirected to the identity provider with a federation context that describes what resource they are trying to access and what type of token the service provider expects. The identity provider in a WS Federation implementation authenticates the user and issues a security token, typically in SAML format, despite the protocol being called WS Federation. This token is then posted back to the service provider through the user's browser. The distinction between WS Federation and SAML 2.0 is primarily in how the federation is initiated and negotiated, rather than in the token format itself. Azure AD supports WS Federation primarily for compatibility with Active Directory Federation services, Microsoft's on-premises federation server. When organizations are migrating from a DFS to Azure AD or maintaining hybrid identity scenarios, WS Federation support ensures that existing applications continue functioning without modification. However, for new implementations, Microsoft generally recommends using either SAML 2.0 or the more modern OpenID Connect protocol. OpenID Connect and modern authentication. OpenID Connect represents the modern evolution of federation protocols, built on top of OAuth 2.0 to provide a standardized authentication layer. While OAuth 2.0 handles authorization, defining how applications obtain access to resources, OpenID Connect adds the authentication component, creating a complete identity federation solution. This protocol has rapidly gained adoption because of its simplicity, mobile friendliness, and alignment with modern application architectures. Unlike SAML's XML-based approach, OpenID Connect uses JSON web tokens, commonly known as JWTs, to convey identity information. These tokens are compact, URL-safe, and easy for modern applications to parse. A typical OpenID Connect authentication flow begins when an application redirects the user to Azure AD with parameters specifying what identity information is needed and what resources the application wants to access. The user authenticates with Azure AD, which then issues an ID token containing claims about the user's identity. This token is a signed JWT that includes standard claims like the user's identifier, name, email, and the time the token was issued. Applications validate the token's signature using Azure AD's public keys, which are published at a well-known endpoint. If the signature is valid and the token is within its validity period, the application trusts the identity claims it contains. Azure AD's implementation of OpenID Connect is particularly powerful because it integrates seamlessly with Azure AD's conditional access policies. When a user authenticates, Azure AD evaluates policies based on factors like user location, device compliance, and sign-in risk. If additional verification is needed, Azure AD can require multi-factor authentication or device compliance checks before issuing tokens. This tight integration makes OpenID Connect the preferred protocol for modern applications integrating with Azure AD. Configuring SAML Federation in Azure AD. Setting up SAML Federation in Azure AD follows a methodical process that establishes the trust relationship between Azure AD and your target application. The process begins in the Azure portal, where you access the Enterprise Applications section of your Azure AD tenant. This is where all third-party applications integrated with your directory are managed, whether they are pre-integrated from the Azure AD Gallery or custom applications you configure manually. When adding a new SAML-based application, Azure AD provides two paths. For applications in the Azure AD Gallery, which includes thousands of pre-integrated SaaS applications, much of the configuration is automated. The gallery entry contains templates that pre-populate the correct URLs and configuration values. For custom applications or those not in the gallery, you select the non-gallery application option and manually configure the SAML parameters. The core of SAML configuration involves establishing the service provider's identity and location. The entity ID uniquely identifies the service provider in the federation relationship. This is typically a URL or URN that the application vendor provides. The reply URL, also called the assertion consumer service URL, is where Azure AD sends the SAML assertion after successful authentication. Some applications require multiple reply URLs to handle different entry points or redirect scenarios. You also configure the claims that Azure AD includes in the SAML assertion. By default, Azure AD sends basic claims like the user's name and email address. However, you can customize this to include any attributes stored in Azure AD, such as department, employee ID, or custom extension attributes. The claim mapping transforms Azure AD attributes into the claim names that the service provider expects, creating compatibility between Azure AD's attribute schema and the application's requirements. Azure AD Federation with Azure CLI. While the Azure portal provides a comprehensive graphical interface for configuring federation, Azure CLI offers a scriptable, automation-friendly approach that is essential for managing federation at scale or incorporating federation setup into infrastructure as code workflows. The Azure CLI commands for managing enterprise applications and their SAML configuration enable IT teams to standardize deployments and ensure consistent configuration across multiple applications or environments. The fundamental command for creating a new enterprise application is a ZADSP create. The SP in this command stands for Service Principal, which is Azure AD's representation of an application instance in your directory. When you create a service principal from a gallery application, you specify the application's template ID, and Azure CLI creates the enterprise application with pre-configured settings. For custom SAML applications, you need to configure the SAML settings after creating the service principal. This involves using a ZAD app update commands to set the identifier URIs, reply URLs, and other SAML-specific parameters. The identifier URI parameter corresponds to the entity ID in SAML terminology, uniquely identifying your application in the Federation Trust. The reply URLs specify where Azure AD should send SAML responses after authentication. Managing SAML certificates through Azure CLI involves commands to list current certificates, configure new ones, and activate them. The AZADSP credential reset command can generate new certificates when existing ones approach expiration, though you must be careful to coordinate this with updates to the service provider's configuration. Azure CLI also provides commands to export the federation metadata URL, which contains all the information service providers need to integrate with your Azure AD tenant. Federation Trust Establishment Process. Establishing a federation trust is a carefully orchestrated process that requires coordination between both parties in the federation. The process begins with planning and agreeing on the federation parameters. Both organizations must decide which protocol to use, what attributes to exchange, and how to handle security requirements, for example, certificate expiration and renewal. This planning phase prevents configuration mismatches that could cause authentication failures. The technical implementation starts with metadata exchange. In a SAML federation, the identity provider generates a metadata document containing its entity ID, certificate information, and endpoint URLs. This metadata is either downloaded as an XML file or accessed through a persistent URL. The service provider imports this metadata into its configuration, establishing the technical trust by storing the identity provider's public key and knowing where to send authentication requests. Simultaneously, the identity provider must be configured to recognize the service provider. For example, in Azure AD, this involves creating an enterprise application. Then, you configure its entity ID and reply URLs to match what the service provider expects. Azure AD then generates its own metadata, which the service provider consumes. This completes the bidirectional trust establishment. Both parties must ensure their clocks are synchronized. This is because SAML assertions include timestamps that are validated to prevent replay attacks. After the technical configuration is complete, thorough testing is essential. Initial tests should use a dedicated test account to verify the authentication flow works correctly. Testing should cover various scenarios including successful authentication, expected failure cases like wrong passwords, and edge cases like users who do not have the required attributes. Many organizations maintain separate Azure AD tenants for testing federation configurations before deploying to production, ensuring any issues are identified in a safe environment. Azure AD B2B Federation. Azure Active Directory Business-to-Business Federation represents one of the most powerful features for modern collaborative scenarios. Unlike traditional guest account models where you create and manage external user accounts in your directory, B2B Federation allows partner organizations to maintain complete control over their users while you maintain complete control over your resources. This creates a clean separation of responsibilities that dramatically simplifies administration and improves security. The architecture of B2B Federation involves establishing a trust relationship at the organizational level rather than the individual user level. When you configure B2B Federation with a partner organization, you are essentially telling Azure AD to trust authentication assertions from that organization's identity provider for accessing specific resources in your environment. This differs from standard B2B guest invitations where external users authenticate with their own credentials, but those credentials are validated directly by Azure AD. There are two primary approaches to B2B Federation in Azure AD. Direct Federation allows you to establish SAML or WS Federation trust with specific partner organizations that use their own identity providers. This is ideal for organizations that want tight control over which partners can access their resources. The alternative approach is to allow Azure AD to handle federation automatically through email one-time passcode or by allowing guests to use their own Microsoft, Google, or Facebook accounts. The resource organization, which is your Azure AD tenant, controls all aspects of authorization. You determine which users from the partner organization can access which resources, what level of access they have, and which conditional access policies apply to them. The partner organization, meanwhile, controls authentication and can enforce their own security requirements like multi-factor authentication or device compliance. This dual control model ensures both organizations maintain their security postures. Configuring Direct Federation. Direct Federation in Azure AD enables you to set up SAML or WS Federation-based trusts with partner organizations that use identity providers other than Azure AD. This is particularly valuable when working with partners who use on-premises Active Directory Federation services, third-party identity providers, or other SAML-compliant systems. The configuration process establishes a trust relationship that allows users from the partner organization to access your resources using their corporate credentials. The process begins by gathering federation metadata from the partner organization. This metadata document contains essential information, including the partner's entity ID, their signing certificate, and the endpoint URLs where SAML requests should be sent. Some organizations publish this metadata at a publicly accessible URL, while others provide it as a downloadable XML file. The format is standardized, so regardless of which identity provider the partner uses, the metadata structure remains consistent. In the Azure portal, you configure direct federation through the external identities settings. Here, you specify the partner's domain, which tells Azure AD that when a user from this domain attempts to access your resources, authentication should be federated to the partner's identity provider rather than handled locally. You then import the partner's metadata, which populates the SAML configuration with the necessary endpoints and certificates. Azure CLI provides a more scriptable approach to configuring direct federation, which is essential for organizations managing multiple partner relationships. The Azure AD Federation command group allows you to create, update, and delete federation trusts programmatically. This enables infrastructure as code approaches where federation configurations are version controlled and deployed through CI/CD pipelines, ensuring consistency across development, staging, and production environments. Claims mapping and transformation. Claims mapping is a critical component of federation that translates attributes from the identity provider's schema into claims that Azure AD and your applications understand. When a user authenticates with their identity provider, that provider issues a token containing various attributes about the user. These might include obvious attributes like name and email, but also organizational attributes like department, employee ID, job title, or custom attributes specific to that organization's directory schema. Azure AD applications expect claims in a standardized format with specific claim names. For example, an application might expect a claim named email for the user's email address, but the identity provider might send this as email address or mail. Claims mapping creates the translation layer that ensures attributes from the identity provider are presented to applications using the expected claim names. Without proper claims mapping, applications may fail to recognize user attributes or make incorrect authorization decisions. The claims transformation capabilities in Azure AD go beyond simple name mapping. You can perform string operations like concatenation, substring extraction, or regular expression matching to derive new claim values from existing ones. For example, if the identity provider sends a distinguished name attribute, you might extract just the organizational unit portion and map it to a department claim. You can also implement conditional claim rules that only include certain claims when specific conditions are met. Claims policies in Azure AD are configured at the service principal level, meaning you can have different claims mappings for different applications even when they are all using the same federation trust. This flexibility is essential because different applications have different attribute requirements. One application might need detailed organizational hierarchy information while another only needs basic identity claims. The claims policy ensures each application receives exactly the information it requires without oversharing user attributes. Conditional access with federation. Conditional access policies in Azure AD provide dynamic, risk-based access control that evaluates multiple signals before granting access to resources. When combined with federation, conditional access becomes even more powerful because you can apply sophisticated access controls to federated users while still allowing them to authenticate with their home identity ID provider. This creates a layered security approach where authentication is delegated but authorization decisions remain firmly in your control. The fundamental concept behind conditional access is the evaluation of signals at authentication time. These signals include user identity, group membership, the application being accessed, network location, device state, sign-in risk, and user risk. Azure AD evaluates these signals against configured policies. It then determines whether to grant or deny access, or to require additional verification steps, such as multi-factor authentication or device compliance checks. For federated users, conditional access policies apply after the user has authenticated with their identity provider but before they are granted access to the target resource. This timing is crucial because it allows your organization to enforce security requirements even when you do not control the authentication process. For example, you might require federated users accessing sensitive financial applications to use compliant devices, even though those users authenticated with their partner organization's identity provider. Location-based conditional access is particularly valuable for federated scenarios. You can configure policies that allow federated users to access certain resources only when they are connecting from expected network locations, like their organization's corporate network or known VPN endpoints. If a federated user's authentication comes from an unexpected country or from a known malicious IP address, conditional access can block the attempt or require additional verification, protecting your resources from compromised federated accounts. Certificate management in Federation. Certificate management is one of the most critical operational aspects of maintaining a healthy federation infrastructure. Certificates serve as the cryptographic foundation of trust in federation, used to sign tokens, encrypt sensitive data, and verify the authenticity of federation messages. When certificates expire or are compromised, authentication fails for all users until new certificates are deployed, making proactive certificate lifecycle management essential. Azure AD uses X.509 certificates for signing SAML assertions and tokens. By default, Azure AD automatically generates and manages these signing certificates with a validity period of 3 years. Approximately 6 weeks before a certificate expires, Azure AD generates a new certificate and begins a rollover process. During this rollover period, both the old and new certificates are active, allowing service providers time to update their configurations to trust the new certificate. The certificate rollover process requires coordination with service providers. Azure AD publishes its current and next signing certificates in its Federation metadata document, and this document is available at a well-known URL. Service providers that regularly refresh their metadata will automatically discover the new certificate and begin trusting it. However, some service providers require manual certificate updates, which requires planned maintenance windows to prevent authentication disruptions. For organizations with strict security requirements, Azure AD supports custom signing certificates. This allows you to use certificates from your organization's public key infrastructure, providing greater control over the certificate lifecycle and potentially enabling longer validity periods or specific cryptographic algorithms. Custom certificates require more hands-on management because Azure AD won't automatically rotate them, but they provide flexibility for organizations that need to align federation certificates with their broader certificate management strategies. Token lifetime and session management. Token lifetime and session management control how long users can access resources without re-authenticating, balancing security requirements against user experience. In federated scenarios, there are actually multiple layers of sessions to consider. The session with the identity provider, the session with Azure AD, and the session with the application. Each layer has its own lifetime configuration and refresh mechanisms, creating a complex but powerful session management architecture. When a user authenticates through federation, the identity provider establishes a session and issues a token with a specific lifetime. This token might be valid for 1 hour, 4 hours, or however long the identity provider is configured to issue tokens. Azure AD validates this token and issues its own token to the application, which typically has a lifetime of 1 hour. The application then establishes its own session, which might last until the user closes their browser or until an absolute timeout occurs. Azure AD provides configurable token lifetime policies that allow fine-grained control over how long tokens remain valid. You can configure different lifetimes for access tokens, refresh tokens, and session tokens. Shorter token lifetimes increase security by limiting the window during which a stolen token can be used, but they also increase the frequency of authentication prompts, potentially degrading the user experience. Finding the right balance depends on your organization's risk tolerance and user population. Single logout, also called single sign-out, is a critical but often overlooked aspect of session management in federation. When a user logs out from one application in a federated environment, ideally they should be logged out from all applications and from the identity provider itself. However, Implementing true single logout is technically challenging because it requires all parties in the federation to support the logout protocol and requires the user's browser to contact each service to terminate sessions. Many organizations accept that complete single logout is not achievable and instead rely on short token lifetimes to limit exposure. Federation troubleshooting fundamentals. Troubleshooting federation issues requires a systematic approach and an understanding of where failures can occur in the complex authentication flow. Federation problems typically manifest as users unable to access applications, getting cryptic error messages, or being repeatedly asked for credentials. The challenge is that the authentication flow spans multiple systems, with each having its own logs and diagnostic capabilities, making it difficult to pinpoint where the breakdown occurs. The first step in troubleshooting is determining whether the problem is with authentication or authorization. Authentication problems occur when the user cannot prove their identity, usually manifesting as login failures or errors during the redirect to the identity provider. Authorization problems occur after successful authentication when the user doesn't have permission to access the requested resource. This distinction is crucial because authentication issues typically point to federation configuration problems while authorization issues point to role assignments or conditional access policies. Browser-based troubleshooting tools are invaluable for diagnosing federation issues. The browser's developer tools allow you to inspect HTTP redirects and examine SAML requests and responses as they flow between the user's browser, the identity provider, and the service provider. SAML assertions are typically base 64 encoded, but numerous online tools can decode them, allowing you to see exactly what claims the identity provider is sending and whether they match what the service provider expects. Azure AD provides extensive logging through the sign-in logs. They record every authentication attempt, including those involving federation. Each log entry includes the user's identity, the application they attempted to access, whether authentication succeeded or failed, and detailed error codes when failures occur. The conditional access details in these logs show which policies were evaluated and whether they blocked access. For federated authentications, the logs also show the authentication method and can indicate whether the problem occurred during the redirect to the external identity provider. Common federation errors and resolution. Federation environments can experience several common error scenarios, each with distinctive symptoms and resolution approaches. Understanding these patterns allows administrators to quickly diagnose and resolve issues before they impact large user populations. The most frequent issues involve certificate problems, metadata mismatches, claim configuration errors, and network connectivity failures. Certificate validation failures are among the most common federation errors. When a SAML assertion signed with a certificate it does not trust is received by a service provider, it rejects the assertion and authentication fails. This typically occurs during certificate rollover periods when Azure AD starts using a new signing certificate but the service provider has not updated its trusted certificates. The error message usually indicates signature verification failed. Resolution requires updating the service provider's configuration to include Azure AD's new certificate, which is available in the federation metadata. Clock skew issues cause intermittent authentication failures that can be particularly frustrating to diagnose. SAML assertions include timestamps indicating when they were issued and when they expire. If the identity provider's clock is more than a few minutes different from the service provider's clock, the service provider may reject assertions as expired or not yet valid. This manifests as seemingly random authentication failures that may work if the user tries again immediately. Resolution requires synchronizing system clocks with a reliable time source like NTP. Claim mapping errors occur when the identity provider sends claims with names or formats that the service provider doesn't recognize. An application expecting an email claim might fail when it receives an email address claim instead, even though the value is correct. These errors often appear as authorization failures or as the application displaying incorrect user information. Diagnosis requires examining the SAML assertion to see what claims were sent and comparing them against the application's configuration. Resolution involves either adjusting the claims policy in Azure AD to send correctly named claims or configuring the application to accept the claims as sent. Federation Security Best Practices. Securing federation infrastructure requires a comprehensive approach that addresses multiple layers of the authentication and authorization stack. Federation introduces additional attack surface compared to traditional authentication because the trust relationship extends beyond your organization's boundaries. However, properly implemented federation can actually improve overall security posture by centralizing authentication and enabling consistent policy enforcement. Certificate security is paramount in federation environments. Private keys used for signing assertions must be protected with the highest level of security, equivalent to root CA private keys. Azure AD stores these keys in hardware security modules, providing tamper-resistant protection. Organizations using custom certificates should employ similar protections, storing private keys in HSMIS or secure key management systems. Regular certificate rotation reduces the impact of potential key compromise, with many organizations rotating certificates annually even when they have longer validity periods. Metadata security often receives insufficient attention, despite being critical to federation security. The metadata document contains public keys and endpoint URLs that service providers use to validate assertions. If an attacker can modify a service provider's metadata configuration to include their own certificate, they can forge assertions that appear to be valid. Organizations should secure metadata documents with HTTPS, implement integrity checking through digital signatures on the metadata itself, and restrict who can modify metadata configurations in both Azure AD and service provider systems. Monitoring and alerting for federation infrastructure should detect both technical failures and potential security incidents. Azure AD's sign-in logs should be continuously monitored for unusual patterns like authentication attempts from unexpected locations, rapid sequences of failed authentications that might indicate credential stuffing attacks, or sudden changes in authentication patterns for federated users. Implementing automated alerting for certificate expiration, metadata update failures, or spikes in authentication errors allows teams to proactively address issues before they impact users. Federation monitoring and reporting. Comprehensive monitoring and reporting are essential for maintaining healthy federation infrastructure and meeting compliance requirements. Federation authentication flows are complex, involving multiple systems and network hops, creating numerous points where issues can occur. Effective monitoring detects problems early, often before users are impacted. It also provides the data necessary for capacity planning, security analysis, and compliance reporting. Azure AD provides multiple tools for monitoring federation activity. The sign-in logs capture detailed information about every authentication attempt, including federated authentications. These logs include the user's identity, the application they accessed, whether authentication succeeded, how long the authentication took, and any errors encountered. You can filter these logs to show only federated authentications, allowing you to analyze patterns specific to external users or partner organizations. Azure Monitor integration enables sophisticated analysis of federation logs through log analytics workspaces. Here you can write custom queries using Custo query language to identify trends, anomalies, or specific authentication patterns. For example, you might create queries that show authentication success rates by partner organization, identify users who are frequently experiencing authentication failures, or detect unusual access patterns that might indicate compromised accounts. These queries can be scheduled to run automatically and trigger alerts when thresholds are exceeded. Reporting requirements for federation often include demonstrating compliance with security policies or contractual obligations with partner organizations. Azure AD allows you to export sign-in logs to storage accounts for long-term retention, satisfying audit requirements that may mandate keeping authentication records for several years. You can also create scheduled reports that summarize federation activity, showing metrics like total federated authentications, success rates by application, and average authentication times. These reports provide visibility to leadership and demonstrate the value and health of your federation infrastructure. Hybrid identity with Azure AD Connect. Hybrid identity scenarios represent a transitional architecture where organizations maintain both on-premises Active Directory and Azure AD, with synchronization between them. This is the reality for most enterprise organizations that have decades of investment in on-premises infrastructure but want to leverage cloud services. Azure AD Connect serves as the bridge, synchronizing user identities, groups, and other directory objects from on-premises Active Directory to Azure AD. In a hybrid identity environment, federation plays a crucial role in determining where authentication occurs. Organizations can choose between three primary authentication methods. Password hash synchronization, where password hashes are synced to Azure AD for cloud authentication. Pass-through authentication, where Azure AD validates credentials against on-premises AD in real time, or federation, where authentication is entirely delegated to on-premises Active AD federation services. Each approach has different implications for security, availability, and user experience. When federation is used in hybrid scenarios, typically through a DFS, users always authenticate against the on-premises federation infrastructure. This means the organization maintains complete control over the authentication process and can enforce on-premises security policies. The trade-off is increased complexity and the need to maintain highly available ADFS infrastructure. If the ADFS servers become unavailable, users cannot authenticate, making redundancy and disaster recovery planning essential. Azure AD Connect configures the federation trust between Azure AD and the on-premises ADFS infrastructure during initial setup. This configuration includes importing the ADFS federation metadata into Azure AD, configuring the federated domains, and establishing the claims rules that transform on-premises Active Directory attributes into claims that Azure AD understands. The result is a seamless single sign-on experience where users authenticate once with their corporate credentials and gain access to both on-premises and cloud resources. Migrating from ADFS to Azure AD. Many organizations are migrating away from on-premises Active Directory Federation services to Azure AD's native authentication capabilities. This migration reduces infrastructure complexity, eliminates the need to maintain federation servers, and takes advantage of Azure AD's advanced security features like identity protection and risk-based conditional access. However, migration requires careful planning because changing authentication methods impacts every user in the organization. The migration process begins with a comprehensive assessment of your current ADFS configuration. You need to inventory all applications integrated with ADFS, document custom claims rules, identify any legacy applications that might only support WS Federation, and understand your organization's authentication policies. Azure AD provides an ADFS application activity report that shows which applications are actively used, helping prioritize which applications to migrate first. For most organizations, the recommended approach is to migrate to password hash synchronization, combined with seamless SSO. This provides a cloud-native authentication experience while maintaining the ability to fall back to on-premises authentication if needed. The password hash synchronization feature syncs a hash of the user's password hash to Azure AD, allowing cloud authentication without exposing the actual password. Seamless SSO uses Kerberos to provide single sign-on for domain-joined devices without requiring users to re-enter credentials. The actual migration is performed in stages to minimize risk. You typically start with a pilot group of users, converting their domains from federated to managed authentication. After validating that these users can successfully authenticate and access all their applications, you expand to additional user groups in waves. Azure AD Connect provides conversion tools that automate much of this process, but thorough testing is essential before converting production user populations. Cross-tenant federation scenarios. Cross-tenant federation addresses scenarios where multiple Azure AD tenants need to establish trust relationships. This typically occurs in mergers and acquisitions, corporate restructures, or when organizations maintain separate tenants for different business units. Unlike B2B collaboration where guest users are invited into a tenant, cross-tenant federation enables more seamless collaboration while maintaining tenant isolation for governance and compliance purposes. Azure AD supports cross-tenant access settings that allow organizations to configure how users from other Azure AD tenants can access resources. These settings operate at the organizational level, meaning you can establish policies for an entire partner tenant rather than managing individual guest accounts. You can control whether users from the partner tenant can access your resources, whether your users can access the partner's resources, and whether B2B collaboration is allowed. One powerful capability of cross-tenant access is the ability to trust multi-factor authentication and compliant device claims from the partner tenant. Normally, when an external user accesses your resources, your conditional access policies would require them to perform MFA or device compliance checks in your tenant. With cross-tenant access trusts, you can accept MFA and compliance claims from the partner tenant, recognizing that they have already satisfied these requirements. This significantly improves user experience while maintaining security. Configuring cross-tenant access requires coordination between both organizations. Each tenant administrator must configure their outbound settings. These settings determine the collaboration they allow with the partner tenant. They also must configure their inbound settings, which determine the access they allow from the partner. The settings include application filtering, enabling you to permit or block access to specific applications. They also include user filtering, allowing you to scope the policies to specific users or groups in either tenant. OAuth 2.0 and token exchange. While federation protocols like SAML and WS Federation focus primarily on authentication, OAuth 2.0 provides a comprehensive framework for authorization, determining what resources an application can access on behalf of a user. Azure AD implements OAuth 2.0 extensively, using it as the foundation for modern application authentication through OpenID Connect, which layers authentication on top of OAuth's authorization framework. The OAuth 2.0 framework defines several grant types, each suited to different application scenarios. The authorization code grant is the most common and secure flow, used by web applications that can securely store a client secret. The implicit grant was designed for single-page applications that run entirely in the browser, though modern best practices recommend using authorization code with PKCE instead. The client credentials grant allows applications to authenticate as themselves rather than on behalf of a user, useful for service-to-service communication. Token exchange in Azure AD involves three types of tokens working together. The authorization code is a short-lived, single-use code that the application receives after successful user authentication. The application exchanges this code for an access token, which grants access to protected resources, and an ID token, which contains information about the user's identity. The refresh token allows the application to obtain new access tokens without requiring the user to re-authenticate, maintaining long-lived sessions while keeping access tokens short-lived for security. Azure AD's token issuance integrates with conditional access policies and other security features. When an application requests tokens, Azure AD evaluates conditional access policies to determine if additional requirements must be met. If policies require MFA or a compliant device, the user must satisfy these requirements before tokens are issued. The resulting access tokens include claims that describe what the token is authorized to access, and applications validate these tokens before granting access to resources. Service principal and app registration. Understanding the relationship between app registrations and service principals is fundamental to working with Azure AD Federation and application integration. An app registration defines an application in Azure AD, serving as the application's identity configuration. It specifies what the application is, what permissions it needs, and how it authenticates. The service principal represents an instance of that application in a specific tenant, controlling what the application can actually do in that tenant. When you register an application in Azure AD, you define several critical properties. The application ID, also called the client ID, uniquely identifies the application across all Azure AD tenants. The redirect UR is specified where Azure AD can send authentication responses, a critical security control preventing token theft. The API permissions declare what Microsoft Graph or other API capabilities the application needs to access. The Certificates and Secrets section contains the credentials the application uses to authenticate itself to Azure AD. Service principals come in three types, each serving different purposes. The application service principal is created when you register an app or consent to a multi-tenant app, representing that specific application in your tenant. The Managed Identity Service Principal is automatically created and managed by Azure for services that need to authenticate to other Azure resources. The Legacy Service Principal exists for backward compatibility with older Azure AD features. Most federation scenarios involve application service principals. The consent framework in Azure AD determines how service principals receive permissions. When a user or administrator consents to an application, they are granting the application's service principal specific permissions in their tenant. User consent allows individual users to grant permissions to applications for accessing their own data. Admin consent requires a tenant administrator to grant permissions, necessary for organization-wide access or privileged permissions. Pre-authorization can be configured for trusted first-party applications, allowing them to access resources without explicit consent prompts. Multi-tenant applications. Multi-tenant applications in Azure AD are designed to serve users from multiple organizations, with each organization's users signing in with their own Azure AD credentials. This model is essential for SaaS applications that serve many customers, where each customer organization maintains its own Azure AD tenant. The application is registered once in the publisher's tenant, but can be provisioned into any Azure AD tenant that consents to it. The technical foundation of multi-tenancy is the sign and audience setting in the app registration. Applications can be configured as single tenant, available only to users in the tenant where the app is registered, or multi-tenant, available to users in any Azure AD tenant. There is also an option for multi-tenant plus Microsoft accounts, allowing both organizational and personal Microsoft accounts. This setting determines which Azure AD endpoints the application can use for authentication. When a user from a different tenant attempts to sign in to a multi-tenant application, Azure AD initiates the consent process. The first time any user from a new tenant accesses the application, they are prompted to consent to the permissions the application requests. If the permissions require admin consent, only a tenant administrator can grant access. Once consent is granted, Azure AD creates a service principal for the application in that tenant, establishing the application's presence and permissions in the tenant. Managing multi-tenant applications introduces unique challenges. The application must be able to distinguish between users from different tenants, typically using the tenant ID claim in tokens. User provisioning becomes more complex because the application needs to handle users from many different directories with potentially different attribute schemas. The application also needs to handle scenarios where consent is revoked, requiring graceful degradation when permissions are no longer available. Publishers must carefully document required permissions and provide clear value propositions to encourage tenant administrators to consent. Federation with external identity providers. Azure AD's support for external identity providers extends beyond other Azure AD tenants or SAML-based systems. The platform can federate with social identity providers like Google, Facebook, and GitHub, enabling customer-facing applications to accept authentication from accounts users already have. This is particularly valuable for business-to-consumer scenarios where requiring users to create new organizational accounts would create friction and reduce conversion rates. Configuring Social Identity Provider Federation involves registering your application with the social provider and then configuring that provider in Azure AD. Each social provider has its own developer portal where you create an application registration, receiving a client ID and client secret. These credentials are then configured in Azure AD's Identity Provider settings, establishing the trust relationship. When users choose to sign in with a social provider, Azure AD redirects them to that provider for authentication, then receives an identity token containing user information. The claims available from social identity providers vary significantly. Some providers, like Google, provide rich profile information, including name, email, and profile picture, while others provide minimal information. Azure AD normalizes these claims to some degree, but applications must be prepared to handle missing or incomplete user information. The email address from a social provider should not be automatically trusted as verified unless the provider specifically indicates it has verified the email. For business-to-business scenarios with organizations that don't have their own SAML or WS Federation-capable identity providers, Azure AD offers email one-time passcode authentication. When a user from such an organization attempts to access a resource, Azure AD sends a time-limited passcode to their email address. The user enters this passcode to authenticate, proving they control the email account. This provides a basic level of federation without requiring the partner organization to deploy complex identity infrastructure. Custom Domain Federation. Custom Domain Federation allows organizations to use their own domain names for Azure AD authentication endpoints rather than the default on Microsoft.com domain. This capability is essential for brand consistency and for organizations that want their users to see familiar domain names during the authentication process. Custom domains also enable features like seamless single sign-on for domain-joined devices and smart lockout based on familiar locations. Adding a custom domain to Azure AD requires proving ownership through DNS verification. You add the domain name in the Azure AD portal, which generates a TXT or MX record that you must add to your domain's DNS zone. After the record propagates, Azure AD verifies ownership by querying DNS for the verification record. Once verified, the domain can be used for user principal names, allowing users to sign in with addresses like user@contoso.com rather than user@contoso.onmicrosoft.com. When a custom domain is configured for federation, Azure AD redirects authentication requests for that domain to the configured identity provider. This is controlled by the domain's authentication type setting, which allows for cloud authentication or federation with an external identity provider. The federation configuration includes the metadata URL or uploaded metadata document from the identity provider, along with settings for preferred authentication protocol and signing certificate preferences. Organizations can have multiple custom domains in a single Azure AD tenant, each potentially configured with different authentication methods. This flexibility supports scenarios like mergers and acquisitions where different user populations need to authenticate against different identity providers. However, this complexity requires careful management to ensure users authenticate against the correct identity provider and that federation metadata remains current across all configured domains. Federation Protocol Comparison. Choosing the right federation protocol involves understanding the strengths, limitations, and use cases for each available option. SAML 2.0, WS Federation, and OpenID Connect each emerged from different ecosystems and serve different needs, though there is significant functional overlap. The choice often depends on what protocols the applications being integrated support, organizational standards, and specific requirements around token formats and authentication flows. SAML 2.0 remains the dominant protocol for enterprise federation, particularly for integration with SaaS applications and for business-to-business federation. Its strength lies in mature tooling, broad support across enterprise applications, and well-understood security properties. SAML tokens are XML-based and can carry extensive attribute information through attribute statements. However, SAML's complexity and XML verbosity make it less suitable for mobile applications or modern web applications that prefer lightweight JSON formats. WS Federation, while still supported, is primarily relevant for legacy Microsoft ecosystems and backward compatibility scenarios. It was the primary federation protocol for Active Directory Federation services before SAML support was added. Modern implementations should generally prefer SAML or OpenID Connect unless specific requirements dictate WS Federation use. The protocol's main advantage is deep integration with Windows authentication mechanisms and support in older .NET Framework applications. OpenID Connect represents the modern standard for authentication, especially for web and mobile applications. Built on OAuth 2.0, it uses compact JSON web tokens and RESTful HTTP APIs rather than XML and SOAP. OpenID Connect's integration with OAuth provides natural support for both authentication and authorization in a single protocol. It is the preferred choice for new applications, particularly those built on modern frameworks, mobile apps, and single-page applications. Azure AD's implementation includes Microsoft-specific extensions that provide rich conditional access integration and seamless single sign-on capabilities. Advanced Federation Architecture Patterns. Complex enterprise environments often require sophisticated federation architectures that go beyond simple two-party trust relationships. These advanced patterns address scenarios like federation chaining, where multiple identity providers are linked together, federation aggregation where multiple source identity providers are consolidated, and federation brokering where an intermediary manages trust relationships on behalf of multiple parties. Federation chaining occurs when authentication passes through multiple identity providers before reaching the final service provider. For example, a user might authenticate with their corporate Active Directory, which federates to Azure AD, which then federates to a partner organization's Azure AD, before finally reaching the target application. Each hop in the chain adds latency and complexity, but this pattern is sometimes necessary when organizations have complex partnership structures or when migrating from legacy identity systems. Hub and spoke federation architecture positions Azure AD as a central identity hub that mediates between multiple identity sources and multiple service providers. This pattern is particularly valuable for organizations with multiple identity sources, such as several acquired companies, each with their own identity infrastructure. Rather than creating mesh federation where every identity provider federates directly with every service provider, the hub pattern centralizes trust relationships in Azure AD, simplifying management and providing a consistent point for security policy enforcement. Federation gateway patterns use Azure AD as a modernization layer in front of legacy identity systems. Organizations with aging identity infrastructure that does not support modern protocols can deploy Azure AD as a protocol translator. Legacy applications authenticate through traditional protocols to on-premises systems, while modern cloud applications use OpenID Connect or SAML to authenticate through Azure AD. Azure AD Connect synchronizes identities between the systems, providing a transition path that allows gradual migration to cloud-native identity without requiring wholesale application re-architecture. Thank you for your attendance. Please consider subscribing to the channel and liking this video.